Part 1, Lab 1, my name is Ahmed. So pin 1 is reset, pin 4 is set input, pin 2 is data input, pin 3 is input, pin 6 is Q naught, and pin 5 is Q, which is Q. It's connected to die. This is the die module. Both 1 and 4 is set to high. From the combination, so 1 is low, so don't press anything, and then you can see the Q node is it's high, Q is it's low. Then the second combination, H high low, the number 2, so it's Q is it's low, Q node is high. Both of them the D and clock are both high, so HH, the Q node, the Q is high, the Q node is low. When it is high, so D is high, the Q node is low, Q node is low. And then number 5, low, so don't press anything. You can just see for myself, it's the same thing. Q is high, 6 clock is high, so the Q node is high, the Q node is high. Number 7 is low, I don't press anything, and the Q node is still high, the Q node is still high. Number 8 H high and then low, so 2, the Q node is still high. Number 9 low, so they're both low, don't press anything, the Q node is still high. Then number 10 H high, D is high, so the Q node is still high. The number 11, they're both high, D and clock, so the Q is high, the Q node is low.
My name is Ubaid, and today I'll be explaining part 2 of lab 2. Okay, so from the function table, we have the SD and RD both set to high, which are connected to 1 and 4. And as you can see here from the breadboard, it's connected to the input, the switch module, and it's set to high. And then we have the input and output as well from the clock module, which is set to 500 kilohertz. And as you can see here from the oscilloscope here, the channel 1 frequency is measured 500 kilohertz, and then the output, which is channel 2, which is measured at 250 kilohertz, which is exactly what we predicted. I'll be explaining part 3 of lab 2. So here we have a 4-bit counter, which I will be demonstrating on the breadboard. Here's the truth table, and here's the schematic that I will be demonstrating in the circuit. Okay, let me just power it up again. Okay, so we have the main input from the clock module, which we are going to set it to 1 hertz. Okay, and I am using an HC161 IC and HC00 IC to demonstrate a 4-bit counter. It's going to count from 1 to 6, and here's the 4-bit version of how it's going to replicate it on the breadboard on the LED module. So this is 1, 2, 3, 4, 5, 6, and then it's going to repeat it again. Okay, so here's it. I'm going to start it up. Okay. Oh, it turned off. Okay, now it's turned on. Alright. So this is 1. This is 2, 3. Okay. It's just keep on. It's repeating. Okay. This is 1. This is 2. This is 3. This is 4, 5, and 6, and it keeps on looping again and again.
I'll be explaining part 5, which is to combine part 3 and 4 for to produce an electronic dice. As you can see, I've set the clock module to 1 hertz, and when I press the button, the dice will roll. As you can see here, it's 1, 2, 3, 4, 5, and 6. This is how it works. And after that, I'm gonna generate the random numbers to, if I set it to 20 kilohertz, 20 hertz, right, it is gonna generate some random numbers. This is 2, this is 5, this is 2 again, this is 5, and 1, 5, 2, 4, 6, 3. Thank you.